Once again, a very good morning to all of you, and welcome to all of you in my new video. And in this video, we shall discuss the one remaining question of exercise 5.2. Show that fx equal to greatest integer x and x lies between 0 to 3 is not differentiable at x equal to 1 and x equal to 2. So, we shall discuss the differentiability of that function at x equal to 1. In my previous video, we have already discussed the differentiability of the function, modulus function, mod x minus 1 at x equal to 1. So, in this case, we shall discuss the differentiability of greatest integer function at x equal to 1 and x equal to 2. So, first, for checking the differentiability of function, we will check the right hand derivative as well as left hand derivative of the function. So, the right hand derivative of the function is given by the formula right hand derivative at x equal to 1 limit h is tending to 0 plus f of 1 plus h minus f of 1 divided by h. So, this equal to limit h is tending to 0 plus f1 plus h. So, this is greatest integer 1 plus h minus greatest integer 1 and divided by h. We know that this is the integer, so its value is 1. This is the integer greater than 1. Suppose its value is 1.2 or 1.3 or 1.4 greater than 1. So its value is equal to 1 because integer less than 1.4 is 1, integer less than 1.2 is also 1. So this value is also 1, this value is 1. So this limit will become limit h is tending to 0 plus 1 minus 1 divided by h. So this is equal to 0. It means the right hand derivative of that function is equal to 0. Now, the left hand derivative of this function limit h is tending to 0 minus f of 1 plus h minus f of 1 divided by h. So, this is limit h is tending to 0 minus, this is 1 plus h minus 1 divided by h. Here h is tending to 0 minus, it means h is tending to 0 minus, it means h is less than 0. So 1 plus h less than 1. It means 1 plus h, this value is less than 1. If this value is less than 1, so greatest integer of any value less than 1 is equal to 0. So, suppose greatest integer of means suppose 0.9, its value is 0. So, this is 0 and the limit h is tending to 0 minus 1 by h. This is not different. This is not different. This is not defined. So here left hand derivative is not equal to the right hand derivative. So function is not differentiable at x equal to 1. Hence f is not differentiable at x equal to 1. Similarly, we will identify or we will check the differentiability of the function at x equal to 2. So there is only slight change, 2 plus h. So 2 plus h, this value is 2 and here is 2 plus h again, but here 2 plus h is less than 2. So less than 2, it means its value is 1. So 1 minus 2, so function is again not defined. There the left and right hand derivative are not equal. So that function is not continuous or that function is not differentiable at all. Now we shall discuss the new topic for the next exercise derivative of implicit functions. So first we shall discuss what are the implicit functions. The function that can be written or that can be expressed. Suppose a function can be expressed, y can be expressed in terms of x, or x can be expressed in terms of y. So that function is not implicit. If we are unable to express y in terms of x or x in terms of y, that function is implicit functions. I will give you one example. If we are unable to express y in terms of x or x in terms of y, the function is called implicit function. Implicit functions. Otherwise, it is called explicit function. For example, I will give you one example. Example is that suppose y equal to 3x plus twice minus x. So here we can not express x in terms of y, or y equal to sin x plus sin xy plus x plus 3. y. In these examples, y cannot be expressed in terms of x, or x cannot be expressed in terms of y. So these are not the implicit functions. So similar, we have to find out the derivative of that functions. How can we find out the derivative of implicit functions? So we will check or find the derivative of implicit functions during this exercise. Suppose one example, I am taking one example for finding dy by dx. If y plus sin y equal to cos x, we have to find out the derivative of a function y plus sin y equal to cos x. So I am using the same technique for finding we will differentiate that function with respect to x, both sides. So differentiate both sides with respect to x. So here differentiation means derivation or differentiation of y with respect to x, dy by dx, plus differentiation of sin y is cos y, and the derivative of y is again dy by dx, and the derivative of cos x is minus sin x. Here taking dy by dx is common, so equal to minus sin x and divided by 1 plus cos of y. So this is the derivative of that implicit function. Now we have to discuss some more examples or questions from the exercise 5.3. So before discussing the exercise 5.3, I would like to discuss the derivative of inverse trigonometric functions. So we shall discuss the derivative of inverse trigonometric functions. Derivative of inverse trigonometric function. First, we shall start with the derivative of y equal to sin inverse x. First, inverse trigonometric function is sine, cos, tan, cot, sec, and cosec. So, we have to find out the derivative of this function. This can be written as sin y equal to x. Now, using the differentiate that function with respect to x both sides, differentiate with respect to x both sides. So we will get derivative of sin y is cos y, and derivative of y dy by dx, and derivative of x is 1. So here value of derivative is 1 from cos y. But here the differentiation is given in terms of x, function is given in terms of x. So we will convert the cos y can be written as 1 minus sin square y, because 1 minus sin square y is cos square y, and root cos square y is cos y, and value of sin y is x. So derivative of y means sin inverse x equal to 1 by under root 1 minus x square. So this is the derivative of sin inverse. Similar, we can find the derivative of cos inverse, tan inverse. So we shall discuss how to find out the derivative of tan. Second one is y equal to tan inverse x. So with the help of by using the property of inverse trigonometric function, this can be written as tan y equal to x, and its derivative sec square y, and derivative of y dy by dx, and derivative of x is 1. So derivative of equal to 1 by sec square y, or derivative of this 1 by sec square y is 1 plus tan square y, and tan y is x. So derivative of tan inverse x equal to 1 by 1 plus x square. Similarly, this is the derivative of sin inverse. Similarly, we can write the derivative of cos inverse. Derivative of cos inverse x equal to minus 1 by root 1 minus x square. This is the derivative of tan inverse. Derivative of cot inverse. Similarly, we can find the derivative of cot inverse x equal to minus 1 by 1 plus x square. Or derivative of sec inverse and cos inverse. Similar. Derivative of sec inverse x equal to 1 by x under root x square minus 1, and derivative of cosec inverse 1 by, this is minus x under root x square minus 1. So these are the derivative of inverse trigonometric functions. So these are fixed new formulas. You have to learn or you have to memorize the derivative of each and every inverse trigonometric function. Now I would like to discuss some examples or some questions from the exercise 5.3, very important and very easy exercise. So up to question number 6 or 7, 8, up to question number 8, these questions are from the, we have to find out the derivative of implicit functions. So I am going to discuss the question number 3rd and question number 8. So question number 3rd is that question number 3rd is that ax plus by square, ax plus b by square equal to cos. Here we cannot express y in terms of x or x in terms of y. So if you are able to express, So then there is no problem. Simply you have to differentiate both sides with respect to x. So differentiate with respect to x both sides. It is a plus b derivative of y is equal to y and derivative of y is 1 dy by dx and derivative of cos y is minus sin y and derivative of y again dy by dx. So something is common. If we transfer that term is here and that term is here, so we will get 2by plus sin y and dy by dx is common equal to minus a. So dy by dx equal to minus a by twice dy plus sin y. This is the derivative of that function. Similar, we will complete the question number 8 of this exercise. The question number 8 of this exercise is that question number 8 is that sin square x plus cos square y equal to 1. So again differentiate both sides with respect to x. हम differentiate करेंगे तो this is the 2 sin x and sin x का क्या होगा cos x plus 2 cos y plus 2 cos y और cos y का क्या होगा minus sin y. उसके बाद y का भी होगा dy by dx equal to 0. So here the value of dy by dx equal to 2 sin x cos x divided by 2 sin y cos y. So this is the result of the question number 8. Now some questions are given. Question number 9, 10, 11, 12, 13, 14 and 15. These are depend on the inverse trigonometric functions. And in these questions, all these questions, you have to check. First, you have to simplify that question and then you will proceed to the derivative differentiation. So question number 9 is that y equal to sin inverse 2x divided by 1 plus x square. So first you have to simplify. In inverse trigonometric function, one exercise is given and some questions are given in which we have to simplify that the result by putting sum x equal to sin, x equal to cos, x equal to tan. So by you have to check which type of formula you can found here. So you will use that type of formula. This is 2 x divided by 1 plus x square. So if we put x equal to tan theta, let x equal to tan theta, and we know that what is this? This is 2 tan theta divided by 1 plus tan square theta. So this is the result of sin inverse sin 2 theta. The result of sin 2 theta, result of cos sin 2 theta equal to 2 sin theta cos theta or 2 tan theta divided by 1 plus tan square theta. Cos 2 theta results are 2 cos square theta minus 1 minus 1 minus 2 sin square theta. Third, cos square theta minus sin square theta. And 4 in terms of tan, 1 minus tan square theta divided by 1 plus tan square. Tan 2 theta, 2 tan theta divided by 1 minus tan square theta. Sin 2 theta हो गया, cos हो गया, tan हो गया, sin 3 theta, cos 3 theta, tan 3 theta. So these are the results that I have already discussed in class 11th. So you have to need to memorize each formula. So this is the result of sin 2 theta. So this is equal to 2 theta. So here y equal to 2 theta. But here y is the function of theta, but y is the function of x. So we have to convert this theta in terms of x. So here the value of theta equal to tan inverse x. So here this is 2 tan inverse x. Now you have to differentiate. So it is very easy to differentiate this term in comparison to this term. अगर आप यहाँ पर डेरिवेटिव करते हैं तो आपके लिए बहुत ही क्रिटिकल होता है, लेकिन अगर यहाँ डेरिवेटिव करेंगे means dy by dx equal to 2 is the constant and derivative of tan inverse x. And we have already discussed the derivative of tan inverse is 1 by 1 plus x. So this is 2 into 1 by 1 plus x square. So the result is 2 upon 1 plus. This is the result. It is very simple. Similar, question number 10 is formula for the tan 3 theta. Question number 11 and 12 both are near about same question. So I would like to discuss out of 11 and 12 we will discuss the one question. Question number 11, y equal to question number 11 is that y equal to cos inverse 1 minus x square 1 minus x square divided by 1 plus x square 0. This condition is given x lies between 0 and we know that. You can observe that here each cos inverse is given. So we have to reduce this result in terms of cos. So we can easily cos and cos inverse remove from that result. For just same as sin inverse is given. So here we will make a result of sin inverse sin is reduced it will be 2 theta. Similar, if we put x equal to tan theta, let x equal to tan theta in the same way. So this is cos inverse 1 minus tan square divided by 1 plus tan square, and this result is cos inverse cos 2 theta, and this is equal to 2 theta, and 2 theta equal to, and the value of theta is again tan inverse x. So y equal to 2 tan inverse x. Similar, differentiate with respect to x, 2 and derivative of tan inverse x is in the same way. And the question number 12 is something different. Here is sin inverse is given and 1 minus x square same is given. So here you will get sin inverse cos 2 theta. You have to convert this cos in terms of sin using pi by 2 minus 2 theta. So you will get that result in the same way. Question number 13 is same as the question number 9. Now question number 14 is very easy. That is given. I would like to discuss 14 and 15 more. So question number 14 and 15. 14 and 15 both are easy question. Y equal to sin inverse. Y equal to sin inverse 2x root 1 minus x square. It is just like 2 sin a cos a, 2 sin theta cos theta. If you will put x equal to sin theta, then this will become cos. So this result is sin inverse 2 sin theta and cos theta. And this value is sin 2 theta. So this is sin inverse sin 2 theta. So this is 2 theta again, and putting the value of theta 2 sin inverse x, using that result dy by dx equal to 2, and value of sin inverse x and derivative of sin inverse x is root 1 minus 1 upon under root 1 minus x square. So this gives the result very easily. After simplifying that result, the derivative is very easy to find out the derivative. In the last question, question number 15 is given is that y equal to sec inverse, y equal to sec inverse 1 upon 2x square 1 by 2x square minus 1. So this is like I have written for some time. I have written that one formula 2 cos square theta minus 1. So if you put x equal to cos theta, so this is 2 cos square theta minus 1. Second one 1 by 2 cos square theta minus 1. And this is sec inverse 1 by cos 2 theta. So this is 1 sec inverse sec 2 theta. And this is equal to 2 theta. 1. Putting the value of theta, theta is cos inverse x. Now using the derivative, dx of y 2, and the derivative of cos inverse is minus 1 upon under root 1 minus x. So this is the derivative of last question. So all questions of this exercise are very easy. So I think exercise is over. So in my next video we shall discuss the derivative of exponential function and derivative of logarithmic function. So thanks to all for watching this video, and घर पर रहिए, सुरक्षित रहिए और बाहर मत निकलिए. धन्यवाद.